And we are live. Hello, everyone. I'm Felipe Hoffa, Snowflake developer advocate. We can play the game. Where in the world is Felipe Hoffa today? I'll let all of you guess. But anyways, I'm today with Andrew Pruski and Frederic Langlaise. How are you doing, Andrew, Frederic?
Absolutely great. Really excited to be here.
Yeah.
Hey, Felipe. Great to be here.
Great to see you. Where are you today? Andrew, where are you getting connecting
So
from?
I'm based in Dublin, Ireland.
You're in Dublin, huh? So we're in a very similar time zone for anyone guessing where I am. And where are you, Frederic?
And I'm in Montreal, Canada.
Montreal, Canada. Nice. So, vous parlez français? Or Montreal parle français?
Nous parlons français.
Ah, très bien. Je ne parle pas français. I barely speak English, but Spanish is my main language. So we are live. People are connecting. I see that this is working on YouTube and on LinkedIn Live. We're ready to answer your questions. And today we're going to discuss Snowpark container services, uh, not from an internal Snowflake perspective, but how the world outside sees it. So, Andrew, how much experience do you have with Snowpark container services?
Not a lot, I'm afraid. That's why I'm here. I'm here to have a listen to Frederic and learn as much as I can.
Cool. How about you, Frederic? How much experience do you have with Snowpark container services?
I have some, but I don't have that much experience in Docker. So this is why we joined forces today to be able to combine both expertise and kind of make sense about our topic today.
Yes. So, Andrew, you happen to work for Pure Storage, but today you are here as doing a community activity as a Docker captain. What is a Docker captain?
Docker Captain's program is just something that rewards people who've worked with Docker and spread information about Docker in the community. So I was really pleased to be welcomed into that community back in December. It's full of people who have vast experiences of knowledge. So nope, really chuffed that happened, and really pleased to be part of that program.
Yeah. How did you end up becoming a Docker captain? What was your interest in Docker?
I was a SQL Server DBA for my sins for about 15 years. And when we test new versions of SQL, we used to have to build VMs, install SQL, test around, and then the new version would come out. We'd have to blow the VM away, test it, build it up again. And it was a long, laborious process. So I remember years ago now, it got to be 2015, talking up to someone, and they mentioned containers, how you could spin up an application really quickly, do your testing, and then when you finish, just blow it away. And that got me really excited. And I just started playing around with SQL Server in containers, and it kind of went from there.
Nice. And that happens to a lot of people that are Snowflake users. We live in a world of data, we love SQL, Python, etc. And suddenly Snowflake introduces the fact that you can run containers inside the Snowflake. But many of us are not familiar with Docker. So it's really cool to say you can just run a container. But if you had to explain a container to people, what is it? Why are they useful?
Well, a container is essentially an isolated environment that contains all the necessary binaries and libraries required by a piece of software so that it can run in the same manner regardless of its environment. AKA, it gets away from the problem of, well, it used to work on my machine, why doesn't it work on your machine? You can bundle up a container into what's known as an image, which is a standardized package, push it up to something called a registry, other people can download it and run it there. And all the containers built from an image will be a carbon copy of all the other containers built from that image. It gives you a known point to run from. And as I said, completely isolated, containing everything it needs to run, no dependencies on the operating system that it's running on.
Nice. So in the container, you can put anything you want.
Pretty much working with SQL Server. So yes, if you can put a high performance database in there, you can pretty much put what you want in them.
Nice. So you could put SQL Server and somehow send SQL Server to Snowflake so Snowflake could run it. And that, I guess, is the entry point for Frederic. What is Snowpark Container Services for you?
Yeah, exactly. So Snowpark Container Services opens up basically a infinite world of possibilities, right? So everything that cannot run today in Snowflake can actually run in Snowpark Container Services. So Snowflake did a super good job in leveraging the database aspect, and we're able to run multiple languages now inside of the engine. But of course, there's so many other things that compose an application today. So think of a web server, for example. Think of if you want to code in different languages that don't necessarily require a CPU but would run better on a GPU. Think of any type of other service that an application would require can now run inside of Snowflake, but in containers. So, of course, what's interesting here is that everything that runs in Snowpark Container Services stays within the boundaries of Snowflake. So we think about security, about governance. You benefit from all these good features, but within the same environment that you're already using Snowflake.
Cool. So let's talk a little bit about your background. Fred, you work at Maxa now. What's your role at Maxa?
Yes, so I'm EVP of Platform Solutions. So I'm the Snowflake SME in my team. So I make sure that we use, Snowflake effectively, use the best features, and I advocate the Snowflake portion of what we do to our customers as we're building native apps at Maxa. We deliver our native apps to the customer Snowflake environment. This is really a new theme for customers. They're not used to that new concept of installing an application on their Snowflake. There's multiple things that they need to understand and be aware of. So this is where my role is played at Maxa.
Right. So let's explain to people what Maxa does, and then I would love to build a story of what Maxa does. How do you know so much about Snowflake, and what does having containers change about your experience with Snowflake? But first, what does Maxa does?
Yes, absolutely. So at Maxa, we built a financial data platform on top of Snowflake. We basically transform systems of records, such as ERP, onto a single system of insights. So think of where we're basically bringing all that data that sits in ERP that's not used properly or presented properly, and we basically will transform this into a unified data model, and then bring all these KPIs and metrics to our customers. We target finance, ops, and supply chain. So think CFOs and their team. That's the way that they want to consume that type of data.
So you're working with financial data. That's really important. And I should correct myself. What does Maxa do? No one corrected me, but my brain was making that noise. So you work with a lot of financial data, and that data, where do these companies store this data?
Yeah, so that data is in ERP systems. Think of SAP, for example, or systems of record. Think of Salesforce. A lot of companies have data on-prem as well, right? So that data is really locked away inside of companies. So to be able to bring that data to the cloud is already, sometimes a big steps for companies to be able to make. And of course, when you want to extend and leverage external services, that data is perceived as very sensitive by customers. And this is where containers will play a big role, is that instead of having to leverage compute in the cloud to provide advanced analytics or services to customers, everything can now run inside of Snowflake securely, so that data does not get out. It stays within the Snowflake boundaries.
Yep. So you were mentioning that you've been a Snowflake user, and you have the ability of run Python code, Java code inside the Snowflake, but suddenly you want to do more, and that's where containers come in?
Yes, exactly. So we're very interested in optimizing our data pipelines. A lot of people are using dbt. dbt is one of the many tools that we use at Maxa as well. So being able to run dbt natively inside of a container, and again, data does not leave the Snowflake boundaries, is something that is really powerful. We're also looking, of course, at leveraging GPUs, which is not possible in Snowflake standalone. So if you want to start to explore LLMs, open source LLMs, to be able to ask questions to our financial data by using natural language. Of course, our customers do not want to use ChatGPT and the likes of open services where their data would be exposed. What they want is their data to be safe inside of Snowflake, and this is where Snowpark Container Services will come into play.
Cool. Yeah, I like how you discuss so many dimensions, because on one hand, everyone loves dbt. I mean, we are a data company. We have a lot of users that are very familiar with dbt. They run dbt outside Snowflake. And you're telling me that, I can run it inside to somehow protect your financial data. So I don't need to move it outside or run external services. And I'm glad that we're going to have a demo right now. And when you mentioned GPUs, Andrew, do you have experience like packaging binaries in Docker that need different environments? How does that work?
As in building basically container images to run applications.
Yeah, so I'm wondering, because you were telling us that a container will run the same anywhere, but somehow if I take the same container and I run it in a computer that has GPUs, the container is able to use that kind of power.
It'll use the resources of the host, yes. So if you run it on a host as opposed to just two, yeah, you can get a little bit more performance. But you can also control the resources that each container uses through, say, Docker commands. That's what Docker does. It makes being able to monitor and utilize container resources very easy, because you avoid then the noisy neighbor scenario where one container takes all the resources of the host, because typically you're running multiple containers on a host. So yes, you can use Docker to limit the resources available to each container to prevent that noisy neighbor situation.
Nice, but also the container itself, where you're running, will be able to use the hardware resources. And
Yes.
Snowflake, in this case, as Frederic saying, you can get different kind of resources out of Snowflake, like GPUs. That's the hot commodity right now. Andrew, you had a demo for us for.
Yes, what I thought we'd do is we're going to package up a simple application, and we're going to push it up to a registry. And all a registry is a remote repository where we can store our container images. So
excellent. So I want to give some background, just some background for our users, because you are really familiar with Docker containers. A lot of our users have never built a container. So I'm glad that you're here to show people that building a container is easy and what does it mean to build a container. So we can go to your screen whenever you are ready.
No problem. Let me share my screen. Okay.
And there we have it.
There we go. So if everyone can see my screen, we're in Visual Studio Code here. And what we're going to do is we are going to bundle up a simple web game into a container. So I'm going to navigate to my repository here. And all we're going to do is take, where are we? This application, which is Pacman, and we are going to bundle it up into a container and get it running first in Docker. And then I'm going to create a container image from it and push it up to the Docker Hub, which is a container registry, which will make that image available to anyone, because I'm going to make it public, to pull down and run it on their platform. So we've got this little repo here. What I did was clone that down and extract it into this file here. Now,
that's your local computer.
This is on my local computer, yes. Now, what we can do to build a container image, we use something called a Docker file. And all a Docker file is a file on my computer which contains some instructions. Hit execute. It's really simple. So we're going to build a container image from the official Nginx image. We're going to use that as our baseline. We're then going to strip out like the default Nginx index page and copy the Pacman game files into that web server directory. We're then going to make a note here just to say expose port 80 to the host. This is the port that the game is going to run on. And then we're going to start up Nginx, and these two little flags here are just to make sure that the application continues to run in the foreground. Containers need an application running in the foreground, otherwise they'll shut down. So that's what we're just doing here. So it's a nice simple, this is how easy it is just to take an application and bundle it up into a container image.
Yeah, so let me, if you can go back just to summarize for people that are really new and to see if I understood. Can you show me the Docker file again?
Yes.
Please. I don't, there it is. So you're taking...
Nice and simple, from the Nginx image.
Yes. The basic thing is you're taking an image, a Docker container that's a web server, and you are able to manipulate it beyond the default. So you're removing some web pages, you're copying a new web pages, that's the Pacman, and exporting port 80. And what people would get out from this is they will build a container that somehow then they're running a web server inside the Snowflake. That's the end goal.
At the moment, we're just going to build it locally and run it locally, and then I'm going to push it up to the Docker Hub to make it available to anyone to run on any platform that they want that has the ability to run containers. And that would be including...
Let's do it.
So let's do it. Yes, let's clear that out. And nice and simple. This is one of the great things about Docker is how simple it is to do everything with it. The commands are really simple. Here I'm just saying, Docker, build me an image, -t, tag it with a name. I'm going to call it Pacman, and then dot. And that just says, look in the local directory for a file called Dockerfile and step through each one of the commands in that Dockerfile to build that image. So 3, 2, 1. And we can see here, it is going through each one of my commands and building me my Docker image. And nice and quick. It's only a small little image. But if I clear this out now and have a look at the images I have locally on my machine, we have our Pacman image built here and size of 50 meg. Now, it says 2 hours ago here that I built it because demo gods can come into play sometimes. So I've got everything as a backup here just in case things can go wrong. But we have our image locally now, just built from that simple command, executing through each of the instructions in our Docker file. So now let's test it. Let's run a container and test that image. And again, it's a really simple command. It's for saying Docker run a container with the name of Pacman, detach, run it in the background so I can continue using this shell. We're going to map a couple of ports. I'm mapping port 8080 on my host to port 80 in the container and from the image we just built. So 3, 2, 1. And that's nice and quick, but let's just confirm that's running. Pacman latest, status up 4 seconds. So that is how easy it is to build an image and get a container up and running. But let's actually prove it. Let's have a look, shall we? Let's come here.
You like using Edge and DuckDuckGo. You're a rebel.
3, 2, 1.
Excellent.
There we go. We've got our game. So I don't know. I'm not going to play much of it, but our game is up and running.
Excellent. We're good to go. This is a web server running inside a Docker container that's running locally in your computer, and you are serving Pacman as we just built it.
Yes, excellent. That's it, absolutely. But we've confirmed that, so let's close that and let's jump back because we've got another stage to go now. I'm going to get rid of the container. We don't need the container anymore. We have the image. So we can say Docker container rm Pacman. We get rid of it. But what I need to do now is I'm going to tag it with a remote repository name so that I can push it up to my remote repository. And so all we do, make sure my remote repository is probably the most popular registry out there, which is the Docker Hub. Nice. Tag my image. And all I'm doing is relabeling that image because this is the name of the repo
DBA from the cold. Cool name.
DBA from the cold is my Twitter handle. So 3, 2, 1. Again, nice simple command, Docker push, and up we go. And there we go. Now, Docker containers are all made of layers. That's why we're seeing these layers already exist. And that's because I've already pushed this image up just in case, I don't know, the demo gods came into play and said, not today, Andrew. But so I already had the image up there. But if we go and have a look now, we can go here, do a refresh.
Pacman.
And boom, DBA from the cold Pacman pushed a few seconds ago. So there we go. That is how simple it is to take a repository to run a game locally, package it up into a Docker container image, run a container from it, and push.
Exactly. Today was a web server. It could be SQL Server, and that's how it all started for you.
It could very much be SQL Server, yes.
And it could
I'll
be
stop sharing my screen.
Anything inside the container. It will just run. And now, Frederic, what would you do with this container?
Yeah, exactly. So my turn.
Let me show your screen. There we are. Now with a familiar Snowflake that most people watching this are familiar with Snowsite.
Exactly. So we're gonna use Andrew's container basically and try to run this in Snowflake and see if we can actually play a game in Snowflake, which is just an example, but a fun example, and then we'll get into real life use cases. So what I'm showing you first in this first section is what I would run in a command line. I'm just gonna show the commands. We're not gonna actually run them, and Andrew and I will back and forth in between exactly what they mean, right? So there's two executables that I would leverage. I would leverage Docker, and I'll let Andrew explain what the commands will do. And then there's the new Snow CLI as well, right? So for people familiar with Snowflake, this is not SnowSQL. This is a brand new CLI that's called the Snow CLI that is open source, and that's going to be used more and more within Snowflake for operations regarding native apps, regarding containers, and regarding other functions in Snowflake. So just like Andrew said, he prepared an image for us that I would be able to Docker pull. This means I would basically download the image on my laptop. And then I would be able to tag that image onto my own image repository that I have in Snowflake, right? So Snowflake will have its own image repository. There's now 2 image repositories that we'll need to work with. One of them is going to be on the Docker side. The other one is going to be inside of Snowflake. Keep in mind that, of course, Snowpark Container Services, we want everything to be self-contained within Snowflake. So that's the way that it's going to work. Then by using the Snow CLI, we're going to prepare this image. So this image will need to be able to communicate with my image registry inside of Snowflake. This is what this very long command will do. Everything that I'm showing you is in the Snowflake documentation. So this is really kind of copy paste, and it's not something that's super difficult to manage. And then by using Docker, we're going to push that image, the image that I have on my laptop that's now been prepared, that I did on the command before, to my image repository. So Andrew, from your perspective, what do you see that's kind of happening here?
Nice.
So you're pulling the image down to your local machine or wherever you're running these commands. And then you're pretty much doing exactly what I did when I was building the image locally. You're using the Docker tag command to relabel that image with your container registry image. So you have the ability to then push it into your own private registry where Snowflake can then access it.
So this is everything that I would do outside of Snowflake. Now, Felipe, we're going to look at something that we're all super familiar with, which is pure SQL stuff that we would do in Snowsite. So the demo has 2 parts. One of them will prepare the environment, right? So think of this as an admin that would perform this. And the other one will be someone that needs to actually create the service and run it. And we'll see the difference between the 2. All right. Cool. So the first portion that I'm going to do is with account admin, right? It could be a lesser role, but it's easier for the demo to just do it like this. The image registry will appear as a database in Snowflake, right? So I have this image registry database, and I have this demo schema, and this is what I'm going to use for my image, basically registry. So if I do that command, show image repositories, I could have multiple, right, ones. I have one that's already up and running. That's going to contain basically my image. And if I call this system, there's a lot of system functions now, right, with these new Snowflake features. So if I call that registry list images, I can see my images. I can have multiple ones, but the one that I'm interested in is the one that's called Pacman, right? So that's the one that Andrew basically prepared for us.
So you took this image from the public Docker registry, but we have a private one, and people would use the private one if they don't want to show their images to the whole world. But we have these options, public or private, but we need to load it to the private one that's for Snowflake to see. You show us the containers that you have there, and this is when you will be able to actually run it.
Yes, exactly.
So, and this is new to Andrew. Like, this is a new thing to Andrew. You know a lot of SQL, but you never done this in a previous database.
No, I have not.
Let me show
up.
Right.
So Snowpark Container Services do not use virtual warehouses, right? They use something different, something new in Snowflake that we call compute pools. They are a bit similar. So this is, compute machines that run in the cloud, but they have, of course, a different purpose. And their purpose is to run something that is containerized, so something that would run inside of Docker, right? So you see my comment here to create the compute pool. I simply call this Pacman compute pool, super simple. I can choose the min and max nodes, right? Similar to what we would have, Felipe, in virtual warehouses. I can pick my instance family. This is similar to the t-shirt size of the virtual warehouse. And this is where I would pick between CPU and GPU, right? So there's multiple sizes that are available. I'm taking one that's very small just for the sake of this demo. I have this auto suspend setting, same thing as a virtual warehouse, very similar, right? I don't want this to run forever if I'm not leveraging this. And then if I say describe my compute pool, you see that this is, a little bit similar to what we would have with a virtual warehouse. And this compute pool can be, right, resumed or suspended. There's a bit of a difference with a virtual warehouse in the sense that virtual warehouse are very snappy. They resume in a fraction of a second. It's going to take a little bit more time for a compute pool. This is expected because it's not something that is available to all Snowflake customers at the same time. It's really for a dedicated customer at the same time.
Yeah, and it has an auto suspend anyways.
Yes, exactly.
That's a cool feature. So
Exactly.
the compute will go down if no one is using the container. Awesome.
Exactly. So when the compute pool is ready, then we're going to prepare the environment. So the first thing we need to grant basically our user that's going to create the service is bind service endpoint. And the reason is that this is what will enable basically to create a service that will support public endpoint. What's a public endpoint? It's a way basically for the outside to communicate with Snowflake on the inside. So our use case today is Pacman, but think of a web server. If you want to run a web server in Snowflake, it's definitely because you want external users to be able to access it by using a browser. So this service endpoint will basically create that unique URL so that users can actually communicate with the service. Then, of course, we're going to grant usage on the compute pool. We want the compute pool to be able to be leveraged as well for the service. And then on the rest of the script here, we're going to basically create a database to host the service. Everything is in Snowflake is a database, right? So it's not unusual to see something like this. So as you see, we have kind of new commands as well that grant create service on schema command. That's going to allow me on the next step to create my service.
Nice. And then
All right.
the permissions.
And then the permissions. So that's kind of the setup on the admin part. Then we're going to jump to what it looks like to actually create the service. And Andrew and I will jump in to explain a little bit what's happening here, basically. So I'm going to use my role, Pacman role. I'm going to point to my database. We can actually see on the left-hand side what the image registry looks like. You see that I have my image registry database, a demo schema, and then I have a stage that I called in my case apps, right? So that's my image registry that I'm going to use a little bit later in my specs. So I'm going to use that command, create service, Pacman demo service, specify which compute pool I want to use, the same compute pool that I used before, and then we're going to get into specifications, right? So in regards to container, Andrew, I believe that you called your container Pacman or your image Pacman, right? So this is where it would come from. Then I'm going to leverage my image repository that's private to Snowflake. And you see here, what's interesting here, you see that I see this as a path, right? Image repository /demo /apps. It's the same, right? Database, schema, and stage. This is the way that it would translate basically to a path. And then my endpoints. So Andrew, as I recall, you mapped your port 8080 to 80, right? And why did you do this?
Yes. Just needed a port locally that wasn't in use. I could have used 80-280. I could have used 15789-280 as long as I was mapping to the port on my local machine that was mapped into the port the application was listed on. In the
and
container.
This will allow me basically to use port 80 without having to specify it in my browser, if you want, right? So if I run show services, I see that my service is now running and active. And then I would do show endpoints in service Pacman. And this is where I'm going to get what we call ingress URL. So ingress URL means to be able to make your way inside of Snowflake. So I'm going to be able to copy this and then paste this into the browser, and hopefully we'll see Pacman running.
Yes.
Right. So I paste this into a browser, and then we have our Pacman.
Ta-da!
Working.
So
Pacman inside of Snowflake.
This is the web server running inside the Snowflake serving the Pacman game that Andrew packaged. That's cool.
Exactly. And we see with the URL, so private URL, but I can still access from a browser. So this is pretty cool.
Yes. Can anyone use this URL right now to play Pac-Man on your Snowflake compute pool?
Yeah, that's a very good question. So of course we have network policies in place which will restrict the users from actually connecting to the URL, and anybody needs to authenticate to Snowflake, which means that this is not available to everyone to use. So
cool. So that would be a reason why we run Docker, a Docker image inside the Snowflake, because you have your users and all of these ports can be protected with your Snowflake authentication.
exactly. So it's a very good point. So it does not mean because you're leveraging containers that this is open to the public and open to the world. So even though you need something that's public facing like a web server, you can restrict traffic and you can make sure that only the required or authenticated users will have access to your service.
Nice. Any thoughts, Andrew, especially for you that you've seen containers everywhere, you've seen databases everywhere. Any reaction to seeing a database running containers?
No, I really liked it. Very, very good. I also like the way that it's really simple to set up. There weren't a lot of steps. There weren't a huge, gigantic load of code, JSON files, things you have to configure. It's very good. Stepping through it very easily to get the image down, pulled, and then deployed.
Yes.
Very nice.
I love the simplicity with how they design the Snowflake team working here of, okay, what would be the natural way to run a container and define what it needs to be defined. Like, from your experience, have you seen, I don't know, just your thoughts. I let you say more. Yeah.
No, it's just it's really interesting. It's pretty much my first experience seeing a application being deployed into Snowpark Container Services. So I came in with no expectations whatsoever, but I really liked how you go with the simplicity. I like simple solutions. I'm a simple person. I like simple things.
And Felipe, from our Snowflake community perspective, what's interesting is that it completely simplifies, if you want, or abstract the complexity of Kubernetes, right? So Kubernetes is, Andrew, I'm sure you agree, it's a fairly complicated technology. It's different from each cloud as a kind of different implementation as well. So as a complete non-Kubernetes expert and non-Docker expert, I'm able to put this together fairly simply with my foundational Snowflake knowledge once the image has been built. So this is what's really interesting. So Snowflake going in the same direction as making the complex simple. This is a new way to abstract all that complexity of containers.
Yeah.
I think it's a really good point because people don't want to spend their time managing a Kubernetes cluster. They just want their applications to be up and running and as quickly and easily as possible. So the fact that it abstracts away that complexity and handles it in the background is really, really appealing.
We should start wrapping up, but we have some live questions. By the way, we didn't get many comments from LinkedIn because sometimes LinkedIn does not deliver me the comments, and that's why we run in parallel on YouTube. And I have 2 questions from our YouTube audience, and let's see what we think about this. It's all about the world of containers, what people are used to do, and how do you see it translating here? Any thoughts from SQL Medic on can we pull an image from the Amazon ECR based on IAM roles? I don't know a lot about Amazon IAM roles, but any thoughts from our panelists today?
Well, Docker 100% absolutely can. You just need to make sure that you're authenticating using those roles in your client before you attempt to pull down from ECR.
Yeah, yes, and from my perspective, the image could come from anywhere, right? The only caveat here is that the image repository in Snowflake cannot communicate directly with the outside. But once the image has been prepared and downloaded locally, then it works.
Yeah, and those are the steps you showed us, Frederic.
Yes, exactly. Exactly the same steps.
Excellent. So we can connect anywhere. Docker can do it, the CLI, but then you need to bring it into your private Snowflake registry.
Yes.
Let's talk about this question from Sebastian from Ecuador. Hola, Sebastian. He's curious about how easy it's to transition from Kubernetes or ECS to Snowpark containers, and what limitations should we be aware of? I guess, Frederic, you
Yeah,
might
so
have.
I'm not able to explain in details the difference, but of course, what we understand is that it completely abstracts, all the intricacies of Kubernetes and removes basically all that complexity, right? So at Maxa, we have Docker specialists, just like Andrew. They bring the foundational knowledge to managing containers and all, but what they say is that it's even a little boring because it's so simple, right? So it removes
Yes.
all the fun of playing with Kubernetes and and managing this. Well, from my perspective, it's a plus.
I'll take if exciting means getting paged at 2:00 in the morning because my Kubernetes cluster's gone down, I'll
Yes.
say boring. Thank you very much.
Yeah, no, when I think about limitations, I guess if we were going to deploy a lot of microservices and orchestrating them, I might as well use a traditional solution. But when we want a simple way to run things within the Snowflake perimeter, this is really an easy thing to do. Again, Frederic, top 3 use cases you can see this being applied in the enterprise data management and data warehousing. That's where you live, Frederic. So
yes, exactly. Super good question. Super good question. So anything that cannot run today in Snowflake would apply. I talked about DBT. So anything that runs with some kind of binary or executable is really interesting. So improving your data pipelines, running languages that are not natively supported in Snowflake. Think of Rust, think of R, for example, or something like that. Anything that would leverage something a little bit more complex. Python, right? So being able if you don't want to leverage Anaconda in Snowflake, but you want to run really your own Python thing, this can run in containers as well. And of course, everything that has to do with GPUs, LLMs, or things like that. Snowflake Cortex is great, but if you want to run open source, again, LLMs, and you want to leverage GPUs in a more private way, containers are perfect for that.
I love it. And I love that these are things that you've been thinking about and putting in production at Maxa. And Andrew, this is new to you, the Snowflake side. But as you know, a lot of databases. And if your imagination had to run wild, what would you do with a container inside your favorite database?
Right. Well, what I love about containers is it separates the compute away from the actual underlying storage. So if we're just talking about containers here, as a SQL Server DBA, we're used to nurturing our SQL VMs, patching them, stroking them, whispering them sweet nothings. Whereas with containers, we don't care about that. We just want something to access that data. So we can do some really cool things with just have a container coming along, running SQL Server, accessing the underlying data, doing whatever workload we want it to do. And then when we're finished with it, we just blow it away. If we need to do something else, we need to spin up something else, we can just spin it up in seconds, run our compute, blow it away when we're finished. But we could do some other really cool things. We can leverage things like I work for Pure Storage. We have a technology called snapshots where we can easily snapshot data, push it into another environment, run a container on top of that, having our compute there, duplicating our data for things like development test pipelines, for things like integrity checking, taking backups. So we can do a whole bunch of really cool things with containerized technologies.
By the way, I have a reaction from Fu Angel to that. Love that. Separates computer from underlying storage. That's a really key point of why we use containers. And let me get the last questions because we need to go back to our jobs. But this is a question from LinkedIn. Oh, let me highlight this question from Tej Kumar. How about the costing and when and where we use containers in terms of data engineering workloads? Any thoughts on the cost of running Kubernetes containers inside the Snowflake, Frederic?
Yeah, a super good question. So the pricing will be a little bit similar to virtual warehouses. There's a new pricing scheme for just for containers. So it's going to vary, right, with the size of the container, right, or the shape of the container that you decide, the number of time it's going to be up, and everything like this. So far, our tests show that it's extremely cost effective, right? So again, with good governance, you should not have surprises in regards to cost.
Yeah, the auto-suspend feature is cool because you are not paying for this container when it's not running, when no one is accessing it.
Exactly.
And with that, I think it's time to close this stream. Thank you, Andrew and Frederic. But before I say goodbye, any last word, any action item, anything you'd like to tell people?
Frederic,
Yeah,
I'll let you
so
go first.
again, we're starting to leverage Snowpark Container Services at Maxa. Super excited with the technology. We're actually joining this with native app, which is, brings again a world of possibilities, because we'll be able to deliver this to our customers. They won't see the container, but they're going to benefit from it. So super excited about the possibilities on our end.
Cool.
And I just want to say thank you, Frederic, for taking us through Snowpark Container Services. Really, really interesting. Thank you so much. And if anyone watching does have any questions about running containers in Docker, please hit me up on LinkedIn. More than happy to
Andrew
answer
Pruski
questions.
on LinkedIn. And I have to say, many times we have Snowflake employees here. I love that today we made it about the community. You work for each for their own company, but Frederic, you are a Snowflake. Andrew, you are a Docker captain. These are community programs of Docker, of Snowflake, and we recognize the experts. And you bring your own expertise of how you see these tools deployed at your companies and how you get to make the best out of them. So thank you so much for bringing that vision. And with that, I'm Felipe Hoffa, developer advocate, and it's time for the polar bear to dance us off. Thanks a lot to everyone.
Thank you.